I'm going to explain the next section here, which does have a little bit of stuff to it. I'm just going to go up to section 2, so just to finish this page, okay? So that's where we're going to go, okay? All right, so if you look at these boxes, one of them for logs, one of them for natural logs, they're essentially the same thing, except one has log, one has natural log, okay? They're essentially the same thing. If you look at the first thing in either case, okay, so I'm going to kind of do them side by side, same thing. The log of any base A, okay, any base A, that could be a 10, it could be a 5, it could be a 3, it could be a 1/4, it could be anything. The log of any base A of 1, if you take the log of 1, or in this case, the natural log of 1, it always equals 0, okay? There's a couple things to know here, and this might be when you like jot down your little notes on the side. Okay, I might not write it right now, but this is definitely like a jot down some notes. Okay, you will never, ever, 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 ever be allowed to put a negative number inside the base or the log. Inside the base or the log, either one of those. Okay, you're not going to be able to write a negative number in any one of those spots. Those are always going to be positive. Okay, always positive. You will never ever see me write log base 2 of -4. Not going to happen. It doesn't exist. Okay, it's not within the domain of log graphing, which we could technically do log graphing. I don't know if we will with e-learning. If we get back into school, we'll definitely do log graphing. Okay, you can't have a negative. No negatives. There. Okay. Just not allowed. You are allowed to have negatives here, though. You can have negatives. Okay, so don't think no negatives can go on the other side. No negatives inside the log part of the problem. Okay? Alright, so get rid of all that stuff. Alright, so what's one rule you got to remember? The log of any base of 1 always equals 0. Okay? And really, if you think about this, here's one way you can think about this. If I said log base 2 of 1 equals, like, I don't know, like y, wouldn't your swoop method say 2 to the y equals 1? And what do you have to raise 2 to the power of to equal 1? Well, what power do you have to raise 2 to equal 1? It's got to be 0. So anything with a 1 here is always going to give a what here? A 0. Okay? Now, you're going to have these notes, you're going to have these videos, you're going to be able to look at your notes, you're going to be able to look at the videos. Again, we don't know exactly how you're going to assess. If you assess, you'll probably need to know it off the top of your head, obviously. But that's one thing to know. The log of 1 with any base is always 0. Okay? Here's another rule. The log where you take the base of the same exact thing of that base number, whatever that is always 1. So log base 3 of 3 is 1. Log base 21 of 21 is 1. Right? It doesn't matter. Log base some number of that same number is 1. And the similar idea is with ln's is e. Because what's the base here? The base is e, and when these two numbers are the same, it basically just cancels out and it gives you 1. Okay? So what's the log base 7 of 7 equal? 1. What's log of 10? Well, what's the base? The base is 10. Those cancel. You get 1. Everything goes away. Okay, no more log. It's not log of 1. It just becomes 1. It's a lot. I know. It's a lot. But you got a lot of time on your hands, so you'll figure it out. Okay? And obviously, you know you can reach out to me. All right, next rule. Here's the next property, and this goes for both sides. Okay, and this is a nice little property that's going to come up often. Okay, if you take a log base, doesn't matter, of something, doesn't matter, but this something that you're taking the log of is raised to a power, is raised to like a bigger exponent or a different exponent. A property is you're allowed to take that exponent and drop it out in front as a coefficient of the log. It is like interchangeable. It is literally interchangeable. When you take the log of something with an exponent, it is interchangeable that it could go in front or it can go in as an exponent on top. One or the other. Okay, it doesn't matter, one or the other. Okay, so like to show you this property, what that means is if I gave you log of x squared, base 10 in this case, you could take this 2 and drop it in front, and really it's like 2 times the log of x. Or if you're like, oh wait, actually I want to go the other way, I want to put this back, it's really again like log of x squared. Okay, and that goes for any base. Doesn't matter what the base is. If you have an exponent, it can be written as a coefficient out in front, and that goes the same for ln. Right? See the exponent here? It can be written out in front to be a coefficient. Okay. When we do problems here in a second, you'll see all these properties come up. Okay. This property, the next one, number 4. Again, a lot of these are just, you just got to remember them and be able to do them. Here's this property. If you take a base and you raise it to a log with that same base, you see that, right? I kind of cross it out here a little bit. It's kind of hard to see. If you take log a and you raise it to a log with that same base, it's like it basically, not just basically, it does. It goes away, vanishes, hashtag math, and what you're left with is the answer, right? So it's like this crazy thing of if you take some base and you raise it to the power of log of that base, that whole thing cancels out and you get whatever that thing you were taking the log of. Same thing applies to ln. Remember there's an e base here. So if you raise e to a natural log of e, which is basically a log with base of the same, that all cancels out and you get x. Okay, so how does that look? If I was like, oh, what's 10 to the log of 4? Well, what's the base of just a normal log? That's a 10. So this whole thing cancels out. You would just get 4. Or maybe I said 3 to the log base 3 of x squared. All of this right here goes bye-bye. And you just get x squared. No more log anymore, just x squared. Okay? Cool. And number 5, and this one's probably the easiest thing to understand. Really not much to do here. If you take the log with, important thing is the same bases. If you take the log of something with a base of a or some base, and you set it equal to a log with the same base, has to be the same base. No questions asked, has to be the same base. Or 2 ln's, has to be the same base. If they're the same base, the only way for this to be true is if this thing equals this thing, right? Log base a of 3 has to equal log base a of 3. So all you have to do is set the things inside. So if I said log of 4 equals log of what? Well, it's the same base. So obviously this has to be a 4. I mean, it's the same thing on either side. Okay, so it's almost like trivial, like you might already know that, or common sense would have thought to do that. Same thing here, as long as you take an ln, aka same base, and these things, then they have to be the same. All right, holy cow, lots of words. I'm talking all day long. Let's do this. Now, here's where this is tricky. I'm not gonna lie, you're gonna know these properties. This is hard. This is tricky. Okay, this is advanced level stuff. Okay, you have to be able to apply these properties. Not every problem is gonna be like, oh, let me look at this problem and see which property it is, right? You gotta maybe do something first and then apply the property, okay? So what do you notice about a lot of these? A lot of these is either make this a 1 or have the same base and value of the log, right? If you can get this to be kind of the same, then some stuff happens. Okay, I almost swore, but it's okay. Okay, some stuff happens, all right? These numbers aren't the same. Is there a way to rewrite 32 so that it's really log base 2 of 2 to some unknown power? That's what we're looking for. Can we rewrite 32 to be 2 to some power? And you're going to get really good at exponents right now, right? You're going to get really good. What's 2 squared? 4. What's 2 cubed? 8. What's 2 to the 4th? 16. What's 2 to the 5th? 32. Good job. And if you didn't say it, then start saying it, okay? 5th. Okay, see how that works? I didn't change anything other than 32 is really 2 to the 5th. I just rewrote it in a form that looks nicer for me, right? I just took this thing and rewrote it. Nothing different. Still means the same problem. 2 to the 5th is 32. I could rewrite it as 32, and it would be the same thing. But why is this helpful? This is helpful because of which property? It's property number 3, which is one of my favorites. Okay? This can go in front. And you have 5 times log base 2 of 2. Exponents can go in front as coefficients. It's interchangeable. Pick them up, put it in front. Okay? How does that help me? What the hell? This doesn't mean anything. Look at that now. When I have the same base and same log value, what do I get when I have the same base and the same log value? 1. This is really like saying this goes away, and it's like 5 times 1, which equals 5. Amazing. Okay? Letter B is actually easier. This one's even easier. It's already done for you. Right? This one we had to kind of rewrite them with the same base. This one already has the same base. See that? The 4 goes in front. 4 times log base 3 of 3. But log base 3 of 3, same base, same value, is 1. See how that works? Okay. You're looking for things. It's kind of like a puzzle. Okay. A lot of people at home, downtime, but you should be good at puzzles by now, right? If you haven't been doing a puzzle in the last couple of weeks, you've wasted an opportunity. Okay. Puzzles are fun. And if you don't like puzzles, well, I don't know what to tell you. All right. This one's hard. This one's a little trickier. Okay. Log base 4, it would be nice if these two numbers were the same. They're not. So what did we do when they weren't the same over here? We rewrote 32 to be that base number raised to some power. Not a 0, technically, to some unknown power. So that's what we want to do here. We want to write this as log base 4 of 4 to some unknown power. And this is where it's a little tricky. You got to think, okay? How could you get 4 to turn into 2 by exponents? And if you say, well, divide by 2, dividing is not an exponent. You might not think of this, but the square root of 4 is really what? Yeah, good job. 2. Okay? Did you know that the square root of 4 is really the 1/2 power? And if you say, no, I didn't, the answer to that is actually yes. We did that in first semester. So really, 4 to the 1/2 power means square root of 4. And that means that this is now rewritten from that. 2 is 4 to the 1/2, or the square root of 4. But then what can we do? Then we can take that power exponent, put it in front, 1/2, times log base 4 of 4, cancel-roni, 1/2 times 1 equals 1/2. Okay? You're going to have lots of problems to try. Okay, and you're going to just have to think through them. And obviously you can text me, you can Zoom call me, whatever, something, okay? Just, you got to think, okay? You got to think. Lots of stuff going on here, okay? All right, next one. Same thing, same rule. You see this over and over and over and over and over. What is the base when there's no base written? That's log base 10. And it'd be helpful to write that. Wouldn't it be nice if this was 10 to some power, some unknown power? And then it would look exactly like all the other problems. Well, how do we make 10 to turn into 1 over 100? Using exponents only. Well, how do you make just 100? Isn't that 10 squared? But have we ever learned a way to make a number turn into like 1 over that, or flip down to the bottom using exponents? Like maybe throw a negative on there? What's 10 to the negative second power? Well, 10 squared is 100, but negative means you flip it. It's like 1 over 10 squared, aka 1 over 100. So you're going to see a lot of fractions, and it's going to turn into negative exponents. This is super important. Okay, talking to some calculus teachers, if you eventually take calculus, this is stuff that people get wrong. After they know all the fancy calculus stuff, then they get this stuff wrong. Okay? All right. So what do we do now? The exponent drops in front. Log base 10 of 10. That cancels. That's really a 1. You get negative 2 is your answer. Okay? All right, same rule applies with natural logs, right? So ln base e of e to the 12th. This can drop in front, exponent. You've seen that 5 times in a row now. And then what's ln of a base with the same number? That always just cancels and goes away, right? Same rules we did up there with logs. Those cancel. It's 12 times 1, which is 12. Okay? Almost like another one. This is like crazy. Like we just did A through F of the exact same problem, just with little different wrinkles. I'll agree. It's a little different. This one, I think the easiest way, really the easiest way, is to rewrite this, again, as e to some power. What would I have to raise e to the power of to turn it into 1 over e to the 5th? Well, obviously, it's got to be a 5, right? But a fraction, 1 over that, makes it a negative 5. So what is this going to do? It's going to drop in front. You get negative 5 times ln of e, essentially. Or if you want to put the little e, you can. This all cancels to be 1 again. You get negative 5. Holy cow. How long is this video? Like 45 minutes? It's crazy. I don't even know. All right. All right, new property. Here we go. New property. Alert, alert, new property. This one's tricky, although it's really actually kind of easy to see because it doesn't happen very often, but when it does, it's kind of easy to notice. It is property number 4. When you raise some number to a log with that same base, that all cancels out. When you raise a number to the log with that same base, it all cancels out. What's the base here? Isn't this an e? So you're raising an e to a log with that base of that same thing. Those cancel out. And you're just left with x squared plus 2. It doesn't drop in front. This is not a drops in front kind of thing because the log goes away. There's no, the 2 doesn't go in front or anything. Okay. Questions? Make sense? Cool. And if you have questions, I couldn't hear that, so sorry. Okay. This one. And then the last property, and this is the easiest property, although it does tend to throw in something I may have mentioned at some point in time, like 100 times, that every single unit we ever do is going to have what in it? Yeah, factoring. And welcome to the factoring moment in logarithms, or at least one of the factoring moments. Anytime you take log base something equal to log base the same thing, that doesn't even matter. Whatever's inside has to be the same. Okay, so x squared minus x just equals 6. Literally, the logs go away. Okay, literally. Okay, factoring. Move it over. Factor. I know you missed this greatly, I'm sure. And you get 2 possible answers for x, which is 3 and negative 2. And don't go away. Don't close the video. I have to explain something. This is the last problem for this video, but I gotta explain something. Okay. Remember way back when, I think I deleted it. I erased it. But remember we said in this general section here, we said that these can't be negative. The base can't be negative, and the number inside the log, no negatives. Okay, can't have it. Now, we won't usually write them, but when you solve, that sometimes can create a negative in there. Okay, you have to check. There could be extraneous solutions whenever you're solving a log equation. Okay, so let's look here. I cannot have the 3 be negative. Oh, well, it's not negative. Okay, cool. I can't have the thing inside here be negative. Okay? So let's check. Let's try 3. Plug in 3. 3 squared is 9. 9 minus 6 is 3. And if you put 3 on the other side, you get 3. So it works. You get 3 on both sides. It's positive. You're good. Okay? What if you plug in negative 2? Here, on this side, you technically get negative 2 squared, which is 4, minus 6, which is negative 2, no bueno. And on this side, you just get negative 2, also no bueno. So negative 2 is no good. 3 is the only answer to this problem. Okay? Can't have negatives inside the logs. Guys, that's a lot. It's a lot of stuff. I'm about to pause this. I can't see from where I'm at right now how long this video was, but it feels like it's been forever. I think my kids are 2 years older right now. I have no idea. But hopefully this has kind of got you through some stuff. There's a lot here. It's really introducing a lot of stuff. Obviously, reach out, watch the video again, look at certain sections again. You'll have problems to try on all this. And I realize, depending on who you are, I may or may not have seen you or talked to you at all yet until you try this a little bit on your own. So do your best, and obviously reach out and send a reminder. Even set up, if you want to set up a Zoom call or something during times. I totally get it. Let's figure it out. Let's make it work. Okay. Talk to you guys later. And not that I really heard anything from you, but hope all is well, and we'll